When we're looking at graphs of inverses, one of the things that we've noticed is that these graphs are reflective about the y equals x axis. That means that if I have one graph, its function, its inverse function is going to be reflected about the y equals x axis. And the reason for that is every coordinate point of one function are swapped around on its inverse. So if I have some point AB, then on its inverse is going to be the point BA. And that is reflection about the y equals x axis. So let's look at a graph and see if we can graph its reflection and kind of see what else we can kind of observe in that process. So let's look at, which one do you think we're going to look at? Yeah, let's look at our buddy x squared. So the graph of x squared, oh, actually, I'm looking at x squared minus 1. Let's add to it. Let's do x squared minus 1. Still part of our fun square that we have, but we wanted to include it not on the origin. All right, what do you notice right now with the x squared graph? Well, yeah, it fails a horizontal line test. It does not meet that objective, so therefore it is not an inverse. It doesn't have an inverse. It's a function, but it's not a one-to-one function. So how do we deal with functions that are not one-to-one functions? Well, how we can deal with them is that we can work with them just on the domain, or we can restrict their domain somehow. So on this one, let's just look at the domain for all values greater than 0, for all x values greater than 0. So we're looking at the right side, and this one does pass the one-to-one function test, the horizontal line test. So what is its inverse? Well, let's look at its inverse then and how we find the inverse of functions. First, we started with f of x equals x squared minus 1. Substitute y in there. Flip the variables around. Solve for y. Take the square root of y. And we're only going to take the principal value of y because we restricted our initial domain to all positive values of x. So we're not going to eliminate the plus or minus. We're just going to deal with the plus side on that one. And that's one of the benefits of restricting this, so we can still look at the graph and get a sense of what we're doing. How do we graph that? Well, remember its graph is the basic square root graph shifted over 1. That's how we can transform graphs. We take the basic square root graph, and I'm not going to draw it all, the basic square root graph, but it had some fashion that kind of like that, shifted back 1. So I'm going to have a graph now that roughly looks along those lines. And what do you notice about that? If I have the right color pen here, well, we'll do this one. It is reflected about the y equals x axis. And so there I was able to identify the inverse of a function that wasn't one-to-one. We did that by restricting its domain so that we were working with the part of the function that could be one-to-one. And once we're able to do that, we're able to find its inverse. Once we're able to find its inverse, we were able to go ahead and graph its inverse. And then I graph both of those on the same plane, so you're able to notice that they are reflective about the y equals x axis. Hey, I think you guys are doing a great job. This kind of concludes the section that we've been working through. We've done a lot of stuff, and I hope you found this helpful in some way. And let me put one little addendum onto that. I wanted to finish up through. There was just a notation thing. It was bugging me. Remember, let's write the notation out. There we go. All right, now I'm happy.